Okay, so in the last video, we did an example using Beer's law. And we said for Beer's law to work, you have to know what absorbance that you want to make, and we used one absorbance. You also have to know the molar absorptivity. So we made up a number, and we said this is the molar absorptivity of the compound when I found it in the reference book. And that's the number that we plugged in. We had the path length, which was B, and that's always a 1. It will always be 1 for you. So that kind of disappears from the equation. And then we had C, which was the concentration. So we did an example. We used the absorbance and the molar absorptivity. We divided them, and we got a concentration of 1.15 times 10 to the negative fourth molarity. So this tells me that based on this compound that I'm working with, if I want a solution that runs one absorbance, then I should make a 1.15 times 10 to the negative fourth molarity of that solution. That's how strong the solution needs to be, or weak the solution needs to be, in order to properly run it onto the machine. But, like I said in the last video, how on earth can we weigh out molarity? Well, we can't, right? We can't weigh out the molarity numbers. It just doesn't work. We need to weigh out grams of stuff, not molarities of things. Okay, so we need to do a little bit of review, or maybe new material that you haven't seen yet in the world of molarity. Okay, so molarity is how strong a solution is. So, you're not old enough to drink. Maybe some of you are. But if you go to a bar and you order a mixed drink, and the bartender gives you the mixed drink, and you take a sip of it, some of you might pucker and say, "Whew, that's too strong. I need you to weaken it down. I can't drink it." Okay, well, that's kind of molarity. That molarity is very high in alcohol. So we weaken it down to make it more tolerable. Same way with molarity. In a laboratory, molarity tells us how weak or how dilute a solution is that we're running or that we're using. So there's an equation that we use to calculate how strong things are. Molarity is equal to moles divided by liter. Okay, so some of you might have a question what a mole is. Well, a mole is just another unit for amount. So for instance, if I said, how many eggs are in a dozen? Dozen is a unit that's used to describe a certain amount. And that amount is 12. Anytime I say a dozen, I think of 12. Right? So a dozen of eggs, 12. A dozen of cats in a crazy cat lady house, that's 12. A dozen of pencils, that's 12. A dozen of lab books for me, that's 12. A dozen can mean anything. You just type on the word dozen, it means 12 of whatever you've got. Mole is the same way. Mole is kind of like a dozen. Mole is a term that we use to describe a specific amount. Okay, well, what is that amount? Well, that amount is very specific. It's 6.022 times 10 to the 23rd molecules of anything. So therefore, if I have 1 mole of sugar, that represents 6.022 times 10 to the 23rd molecules of the sugar. If I have 1 mole of caffeine, well, that represents 6.022 times 10 to the 23rd molecules of caffeine. Right? This is kind of like the 12. 12 eggs in a dozen. 6.022 times 10 to the 23rd molecules of caffeine in a mole. 6.022 times 10 to the 23rd molecules of aspirin in a mole. That is what that term represents. All right? So if I gather this many molecules, 6.022 times 10 to the 23rd of anything, if I gather that many molecules and I carry it over to the balance and I put it on the balance and I weigh it, this will give me weight, grams. Eventually. I need to know something else though in between. But I need to gather that many molecules up, and I can go over and I can put those onto a balance and I can weigh that number of molecules, and it will tell me how many grams that is representative of. Okay, so that's the connection between all of these terms. Mole is an amount like dozen. Well, how many are in a dozen? How many are in a mole? Well, 6.022 times 10 to the 23rd. If I round up that many number of molecules and I weigh them, that weight on the balance is a mole. But I need a connector piece. I need something that makes this that takes these two things and sets them equal to each other. And that's something that we call formula weight or molecular mass. Right? So formula weight or molecular mass. If you've never seen this before, well, we'll go off on another tangent. So let's say that we have water. We need to calculate the formula weight for water. Okay, so the formula weight for water, I look on the periodic table and I find hydrogen. Hydrogen weighs 1.01. I'm just going to round it off to 2 decimals. And oxygen weighs 16.00. Again, I'll round it off. Well, I've got 2 hydrogens here in this case, so 1.01 times 2 is 2.02. And I've got 1 oxygen that's there. It's not written, but it's understood to be a 1, so that would be 16. And I take those 2 and I add them together, 18.02, and the unit here is gram per mole. That means that if I took 6.022 times 10 to the 23rd molecules of water, and I carry that many number of molecules over to the balance and weigh it, it would weigh 18.02 grams. That is the connection and relationship that you need to start making. All right? So in water's case, water's formula weight is 18.02 grams per mole. These are listed on the bottles. These are often also listed in your laboratory practicals as far as math that you don't have to do. But you need to make sure that you're comfortable in doing it because you might be required to do it based on the compound that you've got. So 18.02 grams in every 1 mole of water. If I take 2 moles of water over and weigh it, it will weigh double 18.02. 3 moles of water, it would weigh triple 18.02. If I take a half a mole of water, it would weigh half of 18.02, right? There's the connection piece that many people don't get. Okay, so here we go. Here's my molarity. I know my molarity. My molarity needs to be 1.15 times 10 to the negative 4th molarity. I set that equal to the number of moles, which eventually is going to be converted over to grams. Now I know how to do that. Right here, formula weight will allow that to happen. And the liter is how much do I want to make, right? I don't want to make a liter. That's a lot of waste. So let's say I want to make 100 mils. So 100 milliliters is 0.100 liter. You got to be able to do those conversions as well, right? So milli is 1,000. 1 liter has 1,000 milliliters in it. So if I'm going to make 100 milliliters, that is 0.1 liter. So what I would do is I would start solving this problem. If I solved for moles, that's divide by zero point 0.1. I do the opposite of multiply by zero point 0.1. Okay, so 1.15 times 10 to the negative fourth times 0.1. And then I'm going to hit enter, and I get 1.15 times 10 to the negative 5. Okay, so that's my answer here. 1.15 times 10 to the negative 5 moles. So this equation told me that I need to weigh out 1.15 times 10 to the negative 5 moles. That's what it's telling me to do. My balance does not give me moles. It gives me grams. Therefore, I need to convert that unit over. I need to take my mole and I need to convert it over to gram. Okay, so how do I do that? Well, I set up a dimensional analysis problem. I take my moles divided by 1, and then I bring in my conversion factor. Moles on top, moles go on the bottom. Well, I need to go to grams here. I need to figure out how many grams do I need to weigh out. Okay, so here's my moles. Here's gram. Do I have a connector? And the answer is yes. Right here it is. 18.02 grams per mole. So gram, 18.02 grams. There's gram. So I need to put 18.02 with the gram per, there's my dividing line right there, right? There's my per, 1 mole. So 1 is going to go there. Okay, so now that I do that, I know that I need to take that number and I need to multiply by 18.02 if that's the compound that I'm trying to make, and then I hit enter. And this gives me 2 times 10 to the negative fourth, 2.068, or 2.06 times 10 to the negative fourth grams. You know, that's really little. 0.00002 grams is what I would need to weigh on a balance in order to make this solution. The problem here, though, is that I used water, okay? And sometimes this doesn't really make sense. So let's use something real. I'm just going to kind of mark this out. And let's say that I'm required to make a 1.15 times 10 to the negative fourth molarity solution of aspirin. Well, the formula weight for aspirin is 180.16 grams per mole. So that means in this equation, if I wanted to make that strong of a solution of aspirin, I need to go in and I need to put 180.18 here. Right? This is how many moles that I need to make 100 milliliters of that solution. Mole on top, mole on bottom to gram. There's 180.18 grams in 1 mole. So therefore, I'm going to come here and let me clean this up a little bit. So 1.15 times 10 to the negative fifth times 180.18. And this means that I need to weigh out 0.002 grams. Now, I really need 3 significant figures here, so the first 2's don't count. If you're a sig fig person, it should be 0.00207 grams of aspirin that I would need to weigh out. So that means I would take my aspirin bottle, pure aspirin, and I would weigh out on a balance 0.00207 grams of that substance. And then I would go and get a 100 ml volumetric flask, because look, you said you were going to make 100 mils, right? and I would dump my aspirin down into the volumetric flask, and then I would add DI water up to the etching on the volumetric flask. And then I would turn this upside down and make sure that it was diluted. And when I make that solution, I now have a solution that would run 1 absorbance on the UV Vis instrument. Notice though the problem. The problem is the extremely small amounts that you might have to weigh out. So sometimes what people do is that they will make a solution and they will make it strong on purpose. So that way they can weigh out a manageable amount. And then they will take that and they will dilute it from that point on, because it's easier to do that and to do it the proper way and to get really close absorbance values versus trying to weigh out extremely small amounts of material on a balance in a weigh boat and trying to transfer it over. So that is your example of how to do a molarity question. Molarity equals moles over liter. I know the molarity that I want. I know how much of it I want to make. The moles tells me how much to weigh out. And I need to use the formula weight in order to figure out what that number will be.